For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, looks like we are live, guys, and I am excited for this one. Thank you so much. Looks like we've already got a lively chat. The super stickers are coming in. Thank you so much, Doki Doki, the super sticker master. I appreciate it. So, guys, tonight we're debating the age of the earth, young or old, with two well-seasoned debaters. They're no stranger to debates. We've got Jordan. We've got NephilimFree. They've been here many times, and their debates are always awesome, one to remember. So I'm looking forward to that. Before I go over the format, though, I'm going to announce we've got our good friend David Neff. He is, let me put that up on screen. So after show on David Neff's channel is going to kick off as soon as this debate ends. Also, guys, be here tomorrow at 3 p.m. EST. We've got Professor David McQueen back here with us to finish off his lecture on the Grand Canyon. Okay, so let's see the format for today. We're going to be starting with 12-minute openings, followed by 6-minute rebuttals, and then a 50-minute discussion. We'll end it with a 5-minute closing for each of the debater, and then a Q&A. Guys, so make sure you're tagging me with your questions. I'll save them, and I'll get to as many as I can, of course. Anyways, enough for me. I'm going to hand it over to the debaters. Guys, your mics are on mute, so make sure you unmute yourself. Let's do a brief just introduction before we get into the opening. Not that you guys need any introduction. You've been here so many times, but if you want to plug your channels or Jordan plug your podcast, go ahead. Why don't we start with Jordan? Thank you so much for being here with us again tonight.
Well, thanks for having me on again. For anyone who's not familiar with me, I'm a mechanical and nuclear engineer by training. I used to be a young Earth creationist, but I realized that the evidence didn't support my beliefs, so I changed my beliefs. Like SFT mentioned, I run the Reason to Doubt Skepticism podcast. So if you like what I've got to say, or even if you don't, go check us out. You can tell me in vivid detail exactly why I'm wrong.
Awesome. And Jordan, we always appreciate your willingness to debate and discuss these issues. I don't think there's ever been a time where I've reached out to you and you were not willing to come on and have this important discussion. So I appreciate that. Why don't we hand it over to Neff then? Neff, thanks for being here again. Thanks for giving us your time.
I'm going to enjoy it. It's always fun. Debate is what I really love doing. I'm a young Earth creationist and a Christian. I've been debating and doing Christian apologetics for about 13 years, and I'm really looking forward to this debate.
Awesome. Well, thank you so much, Neff. I'm excited for this. The audience is excited for it as well. I know we're going to have a lively chat, I'm sure. Now, before we went live, we had the debaters choose a number between 1 and 1 billion. And Neff, being the psychic that he is, managed to guess that number being 7. So we decided to, I don't know how you did it, Neff, but you did it. So we decided we're going to have Jordan go first. And Jordan, that means you're going to have 12 minutes. You don't have to start right away. Whenever you're ready, you might want to screen share or something like that. But when you give me the okay, I'll start the timer.
All right. Let's get my screen going here.
Okay, here we go.
Screen's up. All right, cool. So again, thanks for having me on. My position today is that the Earth is about 4.5 billion years old and that the universe is about 13.77 billion years old, both far older than the thousands of years posited by young Earth creationists. To support these claims, I'm going to focus on just 3 lines of evidence: radiometric dating, the Oklo phenomena, and cosmology, which is a branch of physics that studies the origins of the universe. In other words, I'm going to try science. First up, radiometric dating. In nature, there are some unstable elements which will decay, becoming a new isotope and releasing radiation. The original isotope is called the parent, while the new one is called the daughter. The rate at which this happens is called the half-life, or how long it takes for half the sample to change from parent to daughter. We can measure this half-life directly. I've even confirmed some as part of my coursework. The half-life does not appear to change over time and is not sensitive to environmental effects, with electron capture being an occasional exception. This isn't a guess. We can observe this. Therefore, we can calculate how long it takes for a certain amount of parent to turn into daughter. So if we measure a ratio of parent to daughter in a given sample, we can infer its age. Now, every radiometric dating method has its own assumptions and nuances, but they all share that principle in common. Today, I'm going to look at just one of these methods, uranium-lead dating. Zircons are uranium-rich crystals found in igneous rocks which don't form with much lead due to the properties of their crystal lattice. Once a crystal is formed, the interior is a closed system while undamaged. Natural uranium is split into two different isotopes, and each of these decay into two different types of lead at a different rate. That means within each zircon, you have two dating methods for the price of one, giving you a nice self-check. But wait, how do we know that the lead didn't come from, or came from radioactive decay and wasn't just there to begin with? Fortunately, lead-204 doesn't come from radioactive decay. Any lead-204 that's in the zircon then must have been there when it formed, which tells you how much lead was there to begin with if there was any. Because of these built-in double checks, uranium-lead dating is considered to be one of the most reliable methods by the scientific community. This reliability is borne out by consistent results produced on a variety of samples analyzed by different people. For just one example out of thousands, let's look at the Manson meteor crater. In Iowa, the Manson meteor hit the Earth with enough force to fuse quartz at the impact site and toss it far away. This quartz can be found layered between volcanic ash from earlier and later volcanic eruptions. Testing has been done on the quartz and its surrounding sanidine and biotite using multiple dating methods by multiple labs, including uranium-lead dating. If radiometric dating was nonsense, we'd expect these results to be all over the place. Yet you can see from the picture on the right that every single one of these methods agree, showing a perfectly consistent picture of younger rocks on top with older rocks and quartz lower down. If radiometric dating didn't work, this level of agreement wouldn't happen. The oldest rocks on Earth found so far are from Western Australia, dating to be about 4.4 billion years old. Other regions have been found to have similar ages. For example, the Acasta gneiss in Canada is found to be 3.9 billion years old. The moon has been dated to 4.46 billion years old, while asteroids have been dated to 4.56 billion years old. These results didn't have to agree. If the principles of radiometric dating were nonsense, there's no reason to expect that they would agree. The fact that they do agree should bolster our confidence in the conclusion that the Earth is very old indeed. Next, I'm going to talk about the coolest thing that has ever happened, naturally occurring nuclear reactors. In nature, all uranium is about 0.7% enriched. That means about 0.7% of it is U-235, which is the fissile material. The rest is U-238. Over time, this uranium will become less enriched because U-235 decays faster than U-238. By the same logic, if you go back in time, uranium becomes more enriched. In order for uranium fission to work, all you need is 3% enriched uranium and water together in the right place. If you do the math, it turns out that this enrichment would have been achieved about 2 billion years ago. Because of this, Japanese-American and nuclear scientist Paul Kuroda was the first to propose that naturally occurring self-sustaining chain reactions were possible. He made this prediction in 1956, but he didn't expect it would ever be observed. Fast forward to 1972 in the Oklo mine in Africa, where they dug up already depleted uranium ore, i.e. uranium that was significantly less enriched than expected. This caused quite a stir because missing nuclear material is, as you might expect, a big deal. Upon further investigation, it was found that there were significant quantities of fission products also present. These products aren't produced in nature in the amounts observed. They are only found in nuclear reactors. So it's clear what happened. 2 billion years ago, 3% enriched uranium was transported by water to the area of Oklo. That's why there was uranium there to be mined to begin with. 3% enriched uranium plus water kicked off a self-sustaining chain reaction, a natural nuclear reactor. This was an amazing confirmation of Kuroda's prediction, and it requires an Earth of at least 2 billion years old to work. The evidence is so clear that even staunch creationists at AIG and the RAPE project don't dispute that fission occurred. But to solve the problem, since obviously they can't have a 2 billion year old Earth, they propose a simple solution. What if it went faster? If the uranium decayed faster, it would reach 3% enrichment faster, maybe within 6,000 years. Problem solved. Unfortunately, a lower half-life means more radioactivity by definition. The formula relating the two is right there on the screen. To compress billions of years of decay into less than 1,000 years, you have to lower the half-life by a lot, and thus increase the radiation by a lot. Enough radiation, in fact, to be instantly deadly to everything on Earth. Undeterred, creationists have proposed that perhaps all this happened during the flood, so the waters would have shielded Noah and his family from that radiation. Unfortunately, that won't work either, because it turns out that humans, you, me, and everybody else, are radioactive. Inside your body right now is potassium-40 from your food, carbon-14 and radon from the air, etc. For Noah and his family, the dose from their own body would be 132,000 millisieverts every hour, more than the dose from 20 nuclear bombs every hour. Now, I'm not a doctor, but I am confident that Noah isn't going to survive taking 20 nuclear bombs straight to his liver. No amount of flood water is going to shield you from something that's already inside your body. But it gets worse, because all that radiation also puts out heat. Snelling, a young Earth creationist with the RAPE project, calculated that the heat from the compressed decay timeline would raise the surface temperature of the Earth to 22,000 degrees Celsius, 3 times hotter than the surface of the sun. He was unable to find an answer to this problem, leading others to invoke, quote, sustained supernatural processes, i.e. magic, to make it work. If half-lives were sped up to the magnitude required for the young Earth model to work, the Earth would be vaporized and everything on it would be dead hundreds of times over. This evidence clearly points to an old Earth. So now let's move away from Earth and talk about the universe as a whole. Cosmologists tell us that the universe is 13.8 billion years old. Now, today's debate is on the age of the Earth, and technically the universe could be old while the Earth is young. But the typical young Earth model contends that everything, not just the Earth, was made a few thousand years ago. And if the universe, of course, is old, that would undermine that model. So for this part, we'll be looking at 3 pieces of evidence: Hubble's law, the cosmic microwave background, and the observed ages of stars. In 1929, Edwin Hubble wanted to see how the stars were moving relative to us. To do this, he needed to know how far away things were and how fast they were moving. To determine distance, he used what were called standard candles, which are stellar objects having consistent luminosity, such as supernovae and pulsars. By measuring how bright these objects are, we can approximate their distance. The speed at which stars are moving relative to you can be determined by the frequency of the light they emit. The light from objects coming towards you will have a higher frequency, blue shift, while the light of the same object moving away from you will have a lower frequency, redshift. This is analogous to the Doppler effect you hear when cars go past you. As they move towards you, they sound higher frequency. As they move away from you, it's lower. It's not the same physics, but it's analogous. So much to Hubble's surprise, almost everything he saw was redshifted. On this graph, you can see a modern reproduction of his results. The distance to an object is on the y-axis, while the shift, which is proportional to its speed, is on the x-axis. As you can see, not only is everything moving away from us, but the further something is, the faster it is moving. This showed that the universe is expanding, which was an astonishing revelation in 1929. Now, one might wonder, if everything is moving away from us, doesn't that mean we're at the center of the universe? To illustrate why that's not necessarily the case, imagine all the dots in A are planets. The dots in B show the same grid of planets, but the space between each planet has been increased. In other words, their universe is expanding. C shows the point of view from one particular planet. Planet C sees every other planet in its universe moving away from it, and those further away are moving away faster. Remarkably, planet D sees exactly the same thing. Neither one are in the center, but they both see exactly the same observations. The parsimonious explanation, then, is that the whole universe is expanding, and we're not the center of it. If everything is moving away from each other now, if you wind the clock back, it was moving closer together in the past. So you can plug all this information into the formula you see on your screen, and you get an answer for the age of the universe. Though, since the expansion rate hasn't been constant over time, you will need some calculus. You can't just do algebra. This method estimates an age of the universe of between 12 and 14 billion years. Moving on, let's look at the CMB. In 1948, physicists Afer, Gamow, and Herman were studying the early universe. They determined that that universe must have been very hot in order for us to have the amounts of matter we observe today, and they made a prediction. The entire universe would be filled with a glow of that primordial hot gas. The glow would be about 5 degrees Kelvin, or 5 Kelvin, and it would be roughly the same in all directions. Almost 20 years later, in 1965, Penzias and Wilson were working on a new, highly sensitive radio antenna when, completely by accident, they detected a glow, the same in all directions, at about 3K. That's an accident that actually netted them the Nobel Prize. Further observations have confirmed these results. This graph is from the recent Planck mission, which also looked at the CMB. The green line on the graph is the theoretical prediction, while the red is the observation. The green line is almost impossible to see. That's how good the predictions are. They match our observations exactly. This picture of the very early universe gives physicists enough information about the density and structure of that universe when it was very young. That information, combined with our observations of expansion rates, can be used to calculate the age of the universe to a high level of precision. The result of that calculation is 13.77 billion years. Lastly, we can just look at the stars themselves. The larger a star is, the faster it burns through its nuclear fuel. Smaller stars burn slower and dimmer, while larger stars, ironically, burn faster or hotter, and they go out faster. By seeing how bright or dim a star is of a certain mass, we can determine its age. So what they do is they go out, look in the universe, they look for globular clusters, which are the stars at the center of a galaxy. They're all clumped together. one of those globular clusters, M68, is calculated to be approximately 12.2 billion years old based on the composition of its stars. Now, the universe clearly can't be any younger than its oldest star, so this puts a lower limit on the universe's age. Let's review. We have different methods, each based on different sets of observations, independently providing ages of the universe and the Earth, in the case of radiometric dating, that are completely consistent with one another. There's no reason these values had to be this way. Life could exist perfectly well in a universe where these observations would have shown different ages. All these observations agree because they are correct. No matter how you look at it, if you simply follow the evidence where it leads, the conclusion is clear. The Earth is old indeed. And I'll see you the rest of the time.
Awesome. Thank you so much. Okay, I'll get perfect. Let me just go to the timer here, Jordan. Thank you. Just on time, about 25 seconds to spare. So thank you so much for the visuals. And we've already got a couple questions coming in. So thank you to the audience. Just make sure you're tagging me. That way I won't miss the question. And we're going to hand it over to Neph. I see your screen being shared. And whenever you're ready, Neph, you let me know. I'll start your timer. Oh, Neph, you're on mute.
Okay, so let me get I'm ready to go. So I can be seen now. My screen share is working.
You're good to go.
Okay, so when it comes to, the go-to solution for everything for the uniformitarianist is, but dating methods. So, but this problem is a great problem for your, but dating methods. Oh, but the fossil record doesn't show clear, it's dating methods. That's what they do. It's always dating methods. And dating methods are littered with assumptions. For example, if you walk into a room and you find a candle and it's a couple inches tall, when was it lit? You don't know. Because you don't know how tall the candle was. You just can't possibly know. When was it lit? When did the burning process begin? You don't know. So because the rate at which a material decays into another can be discerned with fairly good accuracy, doesn't mean that material has existed that long. It could have been created 6,000 years ago with a decay rate of millions of years. So there are lots of assumptions when it comes to dating methods. Between 1997 and 2006, a team of scientists from the Creation Research Society and Institute for Creation Research conducted radioisotopes and the Age of the Earth project, in which they very diligently and carefully studied a number of factors relating to the age of the Earth. They predicted before they began the study that their results would yield a very young age for the Earth. One of the most important criteria studies that they conducted was how much helium is in the granites of the Earth. They gathered zircon crystals from granites in various locations around the world and sent them to a secular mainstream geology laboratory where they performed dating methods. And they asked them to tell them how much helium is in the zircons. And they came back with a figure. Then they asked them a curious thing. Tell us the rate at which helium escapes from those crystals. Well, being paid to do so, they did. And guess what? Going by the rate, the age, going by the rate at which it escapes and how much helium is in the zircons, the measurements yielded an exact 6,000 years, not 6,200 years, not 5,800 years, 6,000 years precisely for how long that helium could exist in the rocks. So the helium that's trapped in the granites of the Earth prove unequivocally those rocks cannot be millions of years old because there would be no helium in them. Helium is a slippery molecule. It comes out too quickly. There cannot be all this helium in the granites of the Earth if those rocks are millions of years old. It's impossible. It just can't be there. So lots of dating method assumptions. If you find a rock, an igneous rock trapped in a strata, how old is it? Well, you don't know. You don't know when that strata was formed. That rock got trapped in that strata. Unless you know that, how's your dating method going to work? Lots of assumptions. Radioactive elements move to and fro in the earth. This is a problem for groundwater, drinking water. In fact, this from the National Nuclear Security Administration states leaching of uranium and lead and all kinds of things comes and goes in the rocks of the earth. So it provides a serious problem for dating methods, because you don't know, unless you know the exact history of that rock, you can't know how much parent or daughter isotope has been added to or taken from that rock over time. It's impossible to know. This yields a potential 100 million% error for dating methods. 100 million. So how is the error fixed? Well, with assumptions that no material got in and no material came out. Now, furthermore, they're dating volcanic rock, igneous rock. When that rock cools, you can't know that all of the parent-daughter isotope was next to or in the same rock as the daughter isotope, because that rock was molten. It became fixed when it cooled enough to solidify, and that's when however much daughter and parent isotope were fixed in that rock. If it's flowing, it's not likely that all the daughter or parent isotope you find in a given rock will happen to be moving together always as that semi-liquid rock is flowing through the earth and even out onto the surface of the earth. That's not even logical. But that's how evolutionists treat dating methods, as though it's not even something to consider. So 6,000 years for the age of the earth, according to helium. This is research confirming that radioisotope leakage is a great problem for the uniformitarianist. These scientific studies conducted. This is research confirming that the radioisotope. Oh, it's the same slide. Here, let me see. Okay, so I'm going to close that and go back to some more information here. Okay, so how did the planet form? Well, secular scientists are at a loss. They have a theory. It's called the nebular hypothesis, but does it work? Not according to them. In an Astro 2010 paper that's published just 10 years ago, NASA and the University of Michigan scientists working together acknowledged the formation of planets is one of the major unsolved problems in astrophysics. Do they have it nailed down? Do they know how a planet formed by this nebula hypothesis? No, they don't know. They only can assume it had to have happened this way, because that's the only logical way they can think of it having happened with a godless model. But it doesn't work, and that's why it's a problem, or they wouldn't admit that it's a problem. Okay, so here's some amazing stuff. 250 million year old bacteria that came back alive. So a researcher finds bacteria in a salt inclusion that's, according to the uniformitarianist belief about how deep that strata is and how old it must be, that strata had to be 250 million years old, according to their quote-unquote geological column model. So those bacteria are revived in the laboratory, the very bacteria, and that would be impossible. It's impossible. This paper was published in Nature Research. They deleted it. There it is. You can search Nature for it. You won't find it, because this is powerful evidence that kills their ideas. And like good evolutionists, they hide the evidence that refutes the things they claim are true. It was published in Nature, and now it's not there anymore because they got rid of it. So here's more information about that. So DNA has a half-life. And this is the problem for these bacteria. They can't be 250 million years old. It's impossible. Bacteria will decay to nothing in 250 million years. In fact, DNA has a half-life now, it's believed, of 521 years. In 521 years, half of the molecule has decayed into its constituent bits, its other molecules that make it up. You know, the base, the nucleotides and the ribose sugar molecules, that's all you'll have left, because it decays into bits in 521 years. Another 521 years, you have 1/4 of that molecule. Another 521 years, another 1/4 of that molecule. So you see, the bacteria that were revived can't be 250 million years old. They can't even be 200,000 years old. They can't even be 50,000 years old, because it would not be possible to revive them. Their DNA would have decayed into nothing. It would be impossible. So what do the evolutionists do? Well, like every good evolutionist, anytime a scientist produces evidence that argues against what they claim, they throw them under the bus. Oh, he's a bad researcher, bad scientist. They do this constantly. And this is the history of finding soft tissue in dinosaur bones. When they do this, for the last 10 years, the evolutionists have been in denial. Oh, it's not scientific. It's not. Yes, it's young earth creationist. Mary Schweitzer, let's fire her. Let's fire him. Let's can them. That's what they do. They fire anybody who provided this evidence. Now it's been found so many times, they can't do that anymore. They just look bad. So they stopped firing people left and right for it and published themselves. Okay, it really is soft tissue after all. They admit it. So because the firing them scheme stopped working, because the world gets privy to it and says, what the heck are you doing? You're going to fire every scientist that comes up with evidence that argues against your belief? So they did the same thing with this scientist, this Italian researcher, who found 250 million-year-old bacteria and revived them. Oh, he contaminated his sample. Here's carbon-14. Carbon-14 has a tetrahedron formation structure, a lattice. Each molecule bonds to 4 others in vertical space, upside to left and right and below. This is why a carbon diamond is so strong. It bonds, each one bonds to 4 others. But carbon-14 is found regularly in diamonds. The problem is you can't get carbon-14 into a diamond. Carbon-14, diamonds are made of carbon-12. Carbon-14 is a more massive molecule. It has 8 neutrons and 6 protons, whereas carbon-12 has only 6 neutrons. With the lattice structure and the powerful bonds of the carbon molecules in every direction around them, there's nowhere for a molecule to get in. There are only 2 types of molecules that can get into carbon-12, to a diamond rather, and they're smaller than carbon-14. So you can't get carbon-12, you can't get carbon-14 into a diamond. It's impossible. So this proves the diamond had the carbon-14 in the material as it formed. What this proves not only is diamonds are not millions of years old, because, you know, the half-life of carbon-14 is only 5,760 or so years. There can't be any carbon-14 in any diamond if it were even 1 million years old. It's impossible.
1 minute, Neff, 1 minute.
So this proves also that the geological process that allegedly produced the diamond over millions of years didn't take millions of years. It's not possible. That has powerful effect upon geology, you see. That means all of uniformitarian geology is wrong. All of it. If carbon-14 is found in any diamond, everything every uniformitarianist says about geology is wrong, relating to the age of the earth. It's wrong. Dinosaurs lived with man. We've got proof of that. The Earth's magnetic field has a half-life of 1,400 years. It can't be doing that for very long, not even a million years. This is young. The Roche limit proves the Earth is young. The Earth and Moon can never have been close enough to each other, as evolutionists claim. The Moon would have been ripped into bits. And the list of evidences goes on and on. I have much more that I could provide, but I guess I'll have to save that for our open discussion. And that ends my time.
Awesome. Just on time there, Neff. Great openings from the both of you. Loving the visuals. And we've already got a lot of good questions coming in. So now we are moving to the rebuttal period, 6 minutes. I'll give you both a 1 minute warning, just so you can start wrapping up your thoughts around the 5 minute mark. And Jordan, whenever you're ready to go, I'll start the timer. Oh, and Jordan, you're on mute as well. So when you're ready to go.
All right, thanks. So just for fun, I went ahead and Googled the paper that Neff put up there that was deleted. As you can see, it wasn't deleted. I found it on Nature right there. It's been cited 440 times. Awfully hard to cite a deleted paper. So that's a blatant falsehood. It's a lie. I mean, it's either a lie on purpose. I believe that Neff is an honest person, so maybe it was a mistake. Maybe he didn't Google it. But regardless, this wasn't deleted. If it was published, it stayed. There it is. So you can check it for yourself. Now, he argues that this is impossible. Why is it impossible? The paper he put up, I obviously haven't read that paper because I've never seen it before, but just glancing at the headline, it covers a specific set of circumstances, 13 degrees Celsius with low humidity. Does it cover what happens in a salt crystal? I don't know. Does Neff know? I doubt it. So what this is an argument from personal incredulity. I cannot see how it would happen, therefore it didn't. That's not a good argument. Moving back to the top, the whole how tall was the candle when it was lit, that's talking about initial conditions. Now, he went into two different ways. One, he talked about things like, how do you know that the parent and daughter are together? Well, parent and daughter isotopes are isotopes. They are the same element. All elements of the same type are chemically identical. There's no chemical difference between U-235 and U-238. Any chemical process, meaning no nuclear process, will treat the two as the same. So there's no chemical process that's going to preferentially sort U-235 versus U-238. So the reason that they'll stay together in the same homogeneous amount is because the processes that move one will move the other. And we mine uranium all the time. If this weird distribution of uranium was happening, then we would have a reliable amount of 0.7% for all uranium on Earth. We'd be mining the really highly enriched stuff, so we'd have to do less work on enrichment. That doesn't exist. So, yeah, you can also, in radiometric dating methods, there are ways to get rid of the initial conditions. Every radiometric dating method has its own assumptions. Some of them are shared, some of them are unique to the method, and all of these methods agree. So, for instance, you've got argon-argon dating, which includes outgassing. If the argon, you have argon gas that is encapsulated when crystal is formed, you can detect how much was there because there are non-radiogenic forms of argon, just as there are non-radiogenic forms of lead. Just like with the uranium, you can determine how much lead was there in the beginning. Now, so that takes care of that. We don't have to worry about those initial conditions as they're already handled for. We can test for them. We can determine any idiosyncrasies. So the other thing he talked about was it could be created with a half-life of 1 million years. Well, of course it can. I mean, if you have an almighty deity, he can do whatever he wants. He can create everything with the appearance of age 6,000 years ago. But at that point, you're getting into last Thursdayism. If he can create it 6,000 years ago with the appearance of millions of years, why not last Thursday? He could have created it last Thursday with all of the memories and image of everything as today, and there'd be absolutely no way to detect it. That is true. It's as true as it is completely irrelevant. Who cares? It doesn't matter. Unless your God is intentionally trying to deceive all of us, which I don't think you'd agree. I mean, I don't think that I don't want to presume your theology, so if that's the deity you worship, then I apologize. But I don't think that's a deity you worship. Most Christians would say it's not. And so unless this deity of yours is being intentionally deceptive, then it seems like he wouldn't create things with all of the appearance of age so that an honestly questioning person couldn't come to the right conclusion. In terms of the helium, I'll just, first of all, that assumes there's no production. Alpha particles are helium. There are bare helium nuclei. So uranium is producing helium all the time. So you'd have to show that the production isn't sufficient. You assume that there was no production, but that's wrong. The leaching of uranium wouldn't do anything. Again, chemical processes would leach all of the uranium the same, U-238 and U-235, but they don't decay at the same rate. So you'll get a discontinuity between the ages. The U-238 clock won't match a U-235 clock, so it would be obvious if something happened to that effect. Same thing if it came in, it would cause the clocks to misalign. But even if you leached all of the uranium away, all that would do is freeze the clock, which would give it an artificially young age. So the only thing you have proven is that the age is even older than the uranium-lead dating would tell you. So that doesn't help your case. It hurts your case. I mean, if you want to tell me that every uranium-lead zircon has been leached away, so they're all artificially young, then I'll happily concede that. That means I've won the debate. The planetary formation thing, I am not an expert in planetary formation. I know it's an open question, so that doesn't bother me so much. Open questions are why we have science, but I don't know, therefore God is not a good answer. That's a classic God of the gaps problem. 1
minute, Jordan, 1 minute.
Thanks. Mary Schweitzer herself disagrees with you on the soft tissue thing. She was obviously scrutinized very heavily when she came out with this result. That was very surprising. That's how the scientific method works. Ultimately, her evidence was good, so people accepted her results. But she has come out and said strongly that her results do not show any kind of young Earth conclusion. So, you'll have to take that up with Mary Schweitzer. For the carbon-14 and diamonds, prove it. I've never seen a good study of a carbon-14 in diamond that usually they come back with an age of this carbon-14 of about 50,000 years, which is the outer limit of carbon dating. At that point, you have almost no carbon, so we don't use it that far for that reason. And it can also be produced by radiation from uranium, so you'd have to get rid of that as well. It's not enough to undermine all of science. Oh yeah, and diamonds definitely have impurities. They're called interstitial atoms. That's why you have different colored diamonds. So you can definitely get atoms into a carbon lattice. And I think that's my time.
That's your time, just on time. You guys are good. You don't even need me. Here we go. Let me get, okay, so I can restart the timer. And, okay, let me exit the solo screen. And Neph, whenever you're ready, just let me know and I will start your timer. Okay, I see your screen shared. Let me get that going. And 6 minutes when you are ready.
Okay. When radiometric dating processes eliminate all these assumptions built upon assumptions, then they'll become empirical dating methods. They are not. They're littered with assumptions. You said Schweitzer disagrees with me. So the point is the secular community constantly gets rid of, sweeps under the bus, fires, terminates, moves them out, anybody that provides scientific evidence that disagrees with their worldview. And the findings of Schweitzer disagree with the secular worldview, whether she believes it or not. Carbon-14 has been found in diamonds numerous times. I don't know why you don't know this. There can be no carbon-14 in a diamond. Carbon-14 can't get into a diamond. There are two elements that can. They're smaller elements. Carbon-14 is too massive. It's even bigger than the molecule that makes up a diamond. You can't get it in there. It will not go in. There's three things that go inside a diamond. Two tiny elements and light. Nothing else. Carbon-14 is a molecule that cannot penetrate a diamond because of the lattice and because it's a more massive molecule. It's like trying to shove a big professional football player in through a line of much smaller football players. Well, maybe if you have enough force in using football players, but if you're talking about diamond molecules, carbon atoms bound to each other in a lattice, that big pro football player ain't going through that front line. He's too big. He won't get in. So you can't get carbon-14 in a diamond. This empirically proves the Earth cannot be millions of years old. There can't be one atom of carbon-14 in a diamond unless that carbon-14 was part of the diamond when it formed, and that discredits everything about uniformitarianism by itself. Now, there are all kinds of problems with the Big Bang. You mentioned a secular Big Bang as though this is, it's such a given thing. You know, we know that the Big Bang is correct. No, there's countless problems with it. The magnetic monopole problem, large structures in the universe, missing dark matter, the flatness problem, spiral galaxies, the horizon problem. It violates the second law of thermodynamics. The Big Bang violates the first law of thermodynamics, violates Occam's razor, and it has a horizon problem. What you see on the screen is the horizon problem. The horizon problem is this. Heat can only disperse at the speed of light. You can't go faster, only the speed of light. The problem is the difference between the cosmic radiation background, the temperatures is almost nearly perfectly homogeneous in every direction. That can't have happened in 15 billion years. You would need more than 100 billion years because it can't have happened in 15 billion years. You see the red line? The distance between those 2 points is greater than the distance from whatever point in the universe you're looking to that other point on the outside. The inside distance is shorter than the outside one. So how did the heat disperse so that it's so even in every direction? It can't have. It would be splotchy, spotty, and have streaks in it if there was a secular Big Bang. But there isn't, because it didn't happen that way. This just destroys a secular Big Bang. And the horizon problem is a real problem. It's called a problem in astronomy and cosmology because it's a problem. And when they say a problem, that means unsolved. They know of no solution to it. So people like my opponent talk about the cosmic radiation background as though it proved a secular Big Bang. It did no such thing. It argues against it because you need 100 billion or more years for the universe. at least 100 billion years, not 15. It can't have happened in 15 billion years. It's not possible. So the problem with is that none of the empirical methods, none of the methods that my opponent mentions are empirical dating methods. There are limiting factors. The age of the rate at which the Earth's magnetic field is decaying is 1400 years. Secular camp says, well, there's a regenerating dynamo inside the Earth, but nobody can find it. It's just a hand-waving rescue device. Well, there must be a dynamo in there, but there's no evidence for a dynamo to restart or rebuild. And why would it speed up? You see, the magnetic field would increase as the dynamo spins faster, and dynamo is created by the core of the Earth spinning. So you would have to have a core of the Earth that spins faster, then slower, then faster, then slower.
1
that
minute.
makes no sense. That can't be true either. So we know there is no dynamo inside the Earth to rebuild periodically the Earth's magnetic field. It's simply decaying at a rate that tells us the Earth can't even be 1 million years old. The rate at which the materials of the continents are eroding into the seas proves also uniformitarian is flatly false. Millions of meters of material are eroding from the continents every single year. Hundreds of football fields of material every single year, 7 every hour. That's not possible for the continents to be 20 million years old. You take the rate at which the continents are disappearing into the sea, do the math, and the continents can't even be 20 million years old. So there's a lot of things that
10 seconds.
discredit uniformitarianism, and I'd be happy to discuss those with my opponent.
Awesome. Thank you, Neph. And we're good. There's the 6 minutes, guys. Great openings, great rebuttals. This is a great debate so far. We're now moving into the 50-minute open discussion. Okay, so let's make sure to, as always, keep it as cordial and respectful as possible, where both debaters feel like they are getting the necessary and, of course, the fair amount of time to both finish their points and make their points. So here we go. Neph just ended with his rebuttal, so why don't we hand it over to you, Jordan, and you can kick us off for the discussion period. The floor is yours, guys.
Sure. So you say that Big Bang cosmology violates the second law of thermodynamics. Can you expound on that?
Yes. Let's see. Well, it's about entropy. Entropy states that in general all matter has a natural tendency to move toward disorder. But the Big Bang would have had to have created a whole universe as we know it, which has complexity and order in it, and that moves. If there had been a secular Big Bang, the universe should be dust. That's all it should be, dust. You should not have spiral galaxies, and spiral galaxies are a problem. The arms of them move 10 times too fast. They should have flung apart and the inside wound up. The farthest ones we see are just like the nearest ones, and that can't be if they're billions of years old. You see, increasing order from complete chaos. That's actually how it violates the second law.
That's actually not what the second law of thermodynamics states. The second law of thermodynamics states that the entropy, it is not. I'm a mechanical engineer. Thermodynamics is my bread and butter. The second law of thermodynamics states that the entropy in a closed system will increase or stay the same. It's a stochastic statement because the entropy can decrease in a localized area.
When you say it's a closed system, every time an argument comes up against something the evolutionist believes about the Earth, a problem with the Earth or the universe, they talk about everything has got to be a closed system, and they think this solves it. But at which point do you say it's closed? The Earth, a little further out, a little further than that.
The universe. We'll go with the universe.
Yeah. Well, where is the universe end?
So our visible universe, you can call that a closed system if you like. But you can whine about it being a closed system if you want. But that's what the law says. That's what the second law says.
The observable universe is a closed system. What about the unobservable?
Any closed system will have their entropy stay the same or increase. It doesn't say that everywhere in that system the entropy has to increase. That's not what it says. And you know for a fact it's not, because ice freezes. That's a decrease in entropy. It's a local decrease in entropy that happens purely naturally. So there's no problem.
That's not an increase in complexity. Matter moves towards disorder.
That is not what the second law of...
That is a fact.
That's not what the second law of thermodynamics says. You said it violated the second law. That's not what the second law says. The second law doesn't say anything about complexity. It only speaks about entropy.
Right, and entropy. That's what I said.
Yeah, entropy is not the same as...
Entropy is matter moving towards disorder, not order.
No,
the problem is that the universe has allegedly increased in complexity after a Big Bang, and that is complete nonsense.
Neff, that's a false statement.
There's no mechanism for that.
That is a completely
complexity.
False statement.
So you're saying spiral galaxies aren't more complex than a mass of gas?
I'm saying
dust?
Pull up the second law of thermodynamics and show me where complexity is. It's not in there.
Okay, so where is it that you think that do you acknowledge that a spiral galaxy is more complex than just dust, space dust?
Depends on the dust. I haven't done the entropic
depends on the
calculations. It depends on the configuration of the models.
Okay.
You can't use complexity.
Let's say a 1,000 light year wide cloud of space dust. Is that less complex than a spiral galaxy?
That's not enough information to say.
Complexity. I can't get a straight answer.
You're not asking a good question. Complexity is not the same as entropy. Amateurs often say it is because they don't understand the underlying mathematics.
Well, I think your refusal to acknowledge that a spiral galaxy is more complex than a giant space dust cloud is quite absurd and demonstrates that I'm onto something that you don't know how to account for.
No, it demonstrates that you don't understand thermodynamics. Complexity is not part of the second law. Period. The end.
Okay, forget the second law. Is it not true that a spiral galaxy is more complex than a giant space dust cloud?
What? Who cares?
Okay, who cares? Well, it's because order has increased if spiral galaxies were produced.
I have no problem with that. Ice freezes.
Okay, so that's an increase in complexity then, you acknowledge?
Let's say it is. It doesn't matter.
Okay, so that increase in complexity violates the laws of physics because matter moves towards entropy, not order.
No, it doesn't. That's not what the second law states, man. That is not what it states.
Forget the second law. Matter moves towards
what physics
entropy.
does it violate then?
Is it not true that matter moves towards disorder?
No.
Oh, no?
No, it is not true.
In what universe is that not true?
In this universe, the second law of thermodynamics states that entropy increases. Entropy is not this.
Entropy increases.
What entropy is the number of states that you can arrange a system without having a macroscopic difference. That's one way to look at it.
Entropy increases, but you won't acknowledge that a spiral galaxy is more complex than a space galaxy.
Complexity doesn't enter into it.
Excellent.
So it doesn't violate any law. Your question, though.
Oh, okay. Yeah. I think we got our answer. So
we did.
How do you account for the geological processes of this planet that could not possibly be produced by uniformitarianism, such as sedimentary strata and tonguing and pinched tongues in the geologic column, folded mountains? How do you get a folded mountain over millions of years? I'd love to hear any uniformitarianist tell me that. Can you tell me how a mountain of sedimentary rock gets folded and bent over millions of years? Can you tell me that?
You may not be aware of my area of expertise. I'm not a geologist.
Okay, so I remember watching a debate where you had with somebody else, and every time they asked you a tough question, you said, "I'm not a geologist. I don't know this," or "I don't know that. I don't know that." You just hand wave it, right? So wait a minute. But uniformitarianism is true, right? But you don't know the answer to how these things can form under your own model?
I don't know every single item there is to know in science. Okay, I think it would be hubris to claim that anyone does.
So if I asked you lots of questions, you won't have an answer to them either? Like, how does a dropstone get trapped in sedimentary strata inside a mountain?
If you're asking lots of questions about geology, chances are I won't know the answer because I'm not a geologist.
Okay, well, you should be more informed then. If you're going to debate somebody about the age of the Earth, you need to know something about geology.
I know plenty about radiometric dating.
Yeah,
I know plenty.
We know you dug your head into the assumptions of radiometric dating, but that's not going to do it for you. You have to be able to explain how the planet can be millions of years old. Dating methods is a non-empirical dating method. What you need to do is be able to explain how the features of the planet verify the Earth is millions of years old.
I
And I would
appreciate
challenge you to be able to do that.
that you would like me to do that. You should be talking to a geologist. If you're going to be
Okay,
talking
so
to a nuclear or mechanical engineer, we can talk about entropy. We can talk about radiometric dating. We can talk about physics. I have a minor in physics, but I'm not going to pretend to have knowledge that I don't possess.
Okay.
What's happening here is called the Dunning-Kruger effect.
Oh, please.
The Dunning-Kruger effect, it's a bias we're all subject to. You, me, everybody. Humans are really super bad at determining what they're good at. And so you tend to have extremely high confidence in things you don't know very much about.
Oh,
And then, as you
I
know,
don't, but I seem to be able to talk about these things extensively, and yet you can't. And you calling me suffering from Dunning-Kruger.
Yeah.
That's rich. Let me explain to you something. I want you to be able to give an account for the things that you believe, instead of just hand wave them.
I'm not hand waving it. I'm referencing you to an expert. What's wrong with that?
Then you're losing the debate when you can't talk about the things, the features of the planet that you claim demonstrate the Earth is. If all you've got is radiometric dating, you've lost. Because I can talk about all these things.
Then do it.
You can't talk about them? Okay,
then do
what you see on the screen.
No,
can I share my screen?
No, you said radiometric dating is nonsense. Let's talk about it. You made an assertion that radiometric dating is nonsense. Talk about it. Okay.
I said it's non-empirical.
Demonstrate
that. But here's the thing, Jordan. I'm not going to debate you for 50 minutes about dating methods. This is not a debate about dating methods.
Let's talk about cosmology.
It's a debate. It's a method. It's a debate about the age of the Earth. Maybe I've got a lot of knowledge about this stuff that you don't. What you see on the screen is a series of mountains in Alaska. These mountains are bent. You can see that they're folded. They bend up on the left, and a sister mountain range on the right side is bent up on the left. Okay? And in front, you've got an anticline. The problem is this: solid rock doesn't bend.
False.
It breaks.
False.
It has to be 10, more than 10, typically closer to 20 kilometers deep inside the Earth, where the pressure and the heat is present to allow the rock to become pliable.
You literally just answered your own question. Yeah.
Right.
Heat and time.
Oh, okay. Great. So, according to you, these mountains had to have been 10 to 20 kilometers deep inside the Earth.
I'm not going to commit to that because I'm not a geologist. All I'm telling you is I know you are asserting that, but I don't know that you're a geologist either.
Well, that's what geologists say. Okay.
So if you say so, all I'm telling you is I know that solid materials can bend if you subject them to enough heat, because that's how ductility works.
They say so right here. The University of Houston, rocks under low confining pressure near the surface of the Earth, therefore generally deform through fracturing and faulting. Rocks deep within the crust under high confining pressure deform by folding. And here's from Stress and Strain Rock, Columbia University. This occurs in the lower crust and in the mantle, deeper than 10 to 20 kilometers deep. See, that's where rock can become pliable and bend. But then we've got these. See, this is not deep in the Earth. This is on the surface of the Earth.
It isn't today. It isn't now.
This is on the surface of the Earth
today.
But here's what I want you to look at. Do you see the surface of the mountain on the left, right where the arrowhead is? That's the surface of the ground that was pushed up, because that surface goes all the way down to the valley and back up the mountains on the other side. This mountain wasn't 10 to 20 kilometers down. It was the surface of the Earth that was pushed up, and it's curved. The problem is solid rock don't bend. So what you see, Jordan, this verifies for us, is this rock was never solid rock 10 to 20 kilometers down inside. It was the surface of the Earth, and all of it was soft and moist, pliable sedimentary material deposited by the Noahic flood when the pressures in the continent forced the material upward, and it bent. Because it can't bend if it's solid rock. It breaks unless it's 10 to 20 kilometers down inside the Earth.
First of all, a picture is not enough to tell me that it's not breaking. Secondly, again, I'm not a geologist, so I'm not going to understand, and I'm not going to pretend to understand that every single bended mountain, how it formed. That's a great question for a geologist.
Okay, so here's another one. I'll just show you one more to show you how ridiculous uniformitarianism is. This is the Zagros Mountains in Iran. They're folded like an accordion. They were never 10 to 20 kilometers down inside the Earth. This was moist sedimentary materials which were horizontally compressed by pressures in the moving continents during the Noahic flood, and they were folded into parabolic and recumbent folds. The only way that can happen is if that entire mountain range was soft, moist material, when throughout the entire process of its bending, of its folding. And that can't have been millions of years. That had to have happened very fast, in less time than it takes for gravity to suck all the water out of that mountain and create a pool below it. In less time than that.
So
and that means less than 100 years, probably less than a decade.
let's talk about the magnetic field, since you mentioned that. You asserted that the magnetic field decays over time. Is that correct?
That's correct.
Okay. And
it has a half-life of approximately 1,400 years.
Okay, so it only half-life. So if we go back 1,400 years, it should be twice as strong as it is now, right?
Mm-hmm.
Okay, cool.
Yeah.
Unfortunately, that is not what we see. We can check this. Usually, people when they're talking about this talk about the basalt on the ocean floor. But just to mix it up, I decided I'd go a different route. There's another thing.
What is it that we don't see? You say?
I'm sorry.
You say that's not what we see. What is it that we don't see?
Oh, the magnetic field being twice as strong 1,400 years ago as it is today.
Okay.
So
you're saying that scientists have not discovered that the Earth has an apparent half-life of 1,400 years. Is that what you're saying?
I'm telling you that we can measure the magnetic field in the past, and it doesn't go down with a half-life like decaying radioactive material.
Okay. So you're saying that scientists don't agree that the Earth appears to have a half-life of 1,400 years, the Earth's magnetic field, I mean.
I am telling you, because I'm looking at results right now that I'm about to read to you, is that we can look back in time and look at the magnetic field. I've got data right in front of me going back 3,000 years.
Can I screen share, please?
Can I finish my statement? I haven't even asked my question yet.
Yes, go ahead. I was talking to Standing for Truth. Go ahead.
Okay, so if I've got something to screen share, but why don't you go ahead and go first?
Okay, so 1983, scientists discovered the Earth has a 40% more magnetic field 1,000 years AD than it does today. Recent geological geomagnetic reference field, 1970 through 2000, a loss of 1.4% in just 3 decades. Earth's magnetic field is still losing energy. International Geomagnetic Conference field, Russell Humphreys from Creation Research published there. So it's been measured numerous times. Even the secular camp acknowledges that the Earth's magnetic field has decreased remarkably. Okay, so the first paper you see at the top, these are secular guys. That's not creationists. This is published by the United States Government Printing Office in 1967. 5% per century is their estimate. Okay, so this is not a mystery. It's not a secret. Secular geologists are aware that the Earth's magnetic field is decreasing at a phenomenal rate. And that would give it a half-life of 1,400 years. The problem is you have to have an imagined mechanism to rebuild it, and then it decays. Rebuild it, then it decays. Rebuild it, then it decays over and over to keep it from disappearing altogether. Because at the rate at which it's decaying, the Earth can't be even a million years old.
Okay.
See, that's the problem.
Right. So you've made a prediction that if we look back 1,400 years, it will be twice as old. If we look back another 1,400 years, it'll be twice again as old, so 4 times as old, as strong as it is today. That's your prediction. That's what half-life.
No, that's not a prediction. That's measurements.
Okay, cool. Okay. Then in that case, let's look at this. So you assert that it's decaying over time and only goes one way. What you're doing is you're looking at the rate today and projecting it back into the infinite past as if it could never change. Unfortunately, that is not what we observe.
How does it increase?
Dude, can I finish my point? I didn't interrupt you once. Now, fortunately for us, the Earth's magnetic field does not change at a constant rate or a constant direction. Usually this is talked about with basalts, but today I'm going to be talking about pottery because it's more fun. Clays, while they're malleable, they have iron oxides in them, and those iron oxides are vulnerable to the magnetic field. They can orient to the magnetic field just like the iron and basalts can do when they're molten. And then when they're fired, it freezes in place because it can no longer move. So if we look at clay that's been fired in a kiln, it can tell us what the magnetic field was like at the time. We can't tell orientation, obviously, because we don't know which way the pot was turned, but it can tell us magnitude. This was confirmed in magnetic properties of baked clays and their implications for past geomagnetic field intensity determinations by Casanova et al. That was in the Geophysical Journal International 2013. What they did was they took artificial clays and put them in a known magnetic field and fired it, and it confirmed those predictions. So with that methodology, researchers in Syria and Israel have conducted tests on clays that have been fired by the ancient Israelites. They kept meticulous records about history, and so we have these seals and other things that are fired along with historical records, so we can confirm it not just with radiometric dating, but also with historical methods. That information goes back, that group. So this one is, I'll just go up to the top, page 15. So this is the paper. It was published in +1, and there's the people that did it, and we can look at the relevant data here. This is 1100 BCE to 0. You can see that the strength of the field is 110 amps per meter squared times 10 to the 21, I believe. And you can see it oscillates. There's even spikes, so it doesn't go straight up and down. It oscillates. There's and it ends here and starts there. That is not quite 1400 years, but it is close to 1400 years, and it definitely did not double. Then we can take it further than that and go from 0 to the 2000. Once again, no doubling in strength. It oscillates. We've been going down from about 800 to now, roughly. Doesn't go in one line. It oscillates. But you can see we were higher than that before, and we've been lower than where we are in the past. So your prediction that we have a half-life that goes down consistently is not demonstrated in the data.
Okay, so then your assumption about this particular paper contradicts the numerous times that scientists have measured the magnetic field of the Earth, which shows it's continuously decreasing. All you've shown is that the clay used to make those pots in that one location on the Earth don't match the papers that have been published on it. That's all you've demonstrated.
See, and here you go. You didn't like the research I showed you. You didn't like the methodology.
I'm just telling you that if you apply your assumption that this must be the case all over the Earth, and which is what you're doing, it contradicts the papers, the scientists who've been publishing about the magnetic field of the Earth for decades. Okay. So that demonstrates that you've got an assumption built in there.
You are correct.
Understand that? Okay, that is correct.
Dude, if you keep interrupting me, I'm just going to end.
Look, we're having a talk. I mean,
yeah, and
it's not
you talk,
like
then I talk. That's how conversations work.
Right, but when I try to say something, you jump in the gun. Go ahead, talk.
So, this does include, it doesn't include an assumption per se. It is a fact that when you're looking at a piece of clay, it can, of course, only tell you about the magnetic field where that clay was fired. So is it your assertion, then, that the magnetic field decays exponentially everywhere else, but not in Israel and Syria?
I would say it's an exception. There's always exceptions to things, for crying out loud. But if we apply your assumption that it must be the same all over the Earth throughout history, then it contradicts the other scientists who published about the decay of the Earth's magnetic field. Because it's not argued about. Secular scientists are all on board. The Earth's magnetic field seems to be decaying at an astonishing rate.
Now.
The way they fixed the problem, right now. See, now we're getting back to the truth. Right now, yes. But you have to have a model that jump starts it again, that it goes up and down, it oscillates wildly from strong to weak, strong to weak, strong to weak. What is that mechanism, please?
I believe the leading model is the dynamo theory. It's not my area of study, but it's an open question. It's still an area of active research. What I can tell you for sure is that we can see that right now in the data that I'm showing you.
How is the dynamo generated? Is it not by the turning of the Earth's core? Is that not correct?
My understanding, and again, not a geologist, is that it's done by electrical currents. Whenever you have metal thing turning, it's going to generate a current.
Right, but it's the core of the Earth spinning that causes the magnetic this dynamo. Is that not correct? That's what secular camp claims.
Okay.
That's what they say, right?
Okay.
So if it increases and decreases, that means the core of the Earth has to accelerate and decelerate, accelerate and decelerate. Otherwise, it remains constant. What's the logic behind believing the Earth's volcanic magnetic core is increases in velocity, then decreases and increases and decreases, especially since you believe the Earth was formed by the nebular hypothesis, in which matter accreted into a ball. It got hot in the center for some reason, and then is cooling ever since and slowing down as it rotates. How could the Earth's core accelerate and decelerate? What's the mechanism for that?
I'm not familiar enough with the model to say that it even does accelerate and decelerate. That's just not my area of expertise. What I can tell you for sure is that your prediction of a half-life is wrong, or it's either
It's
wrong.
not a prediction; it's a measurement.
You say that, but I'm
Well,
showing you
that's what
measurements right now. You say that, you quote the scientists showing that the magnetic field is decaying right now, today, and you're saying, oh, so if it's decaying like this right now, it definitely did that forever, and therefore you're wrong. That's not what the scientists are saying. I guarantee you, if you went back, they would. Yeah, of course not, because that's ridiculous.
Of course. No, instead they invent some ridiculous idea that there's a dynamo that increases it and then it decreases, and then it increases and decreases, which would require the core of the Earth to accelerate, then decelerate, accelerate and decelerate. And I just want to know the mechanism for that, because they don't have a clue and they don't give one.
So the point is that your assertion that this violates...
The problem is, Jordan, you're assuming that there is a dynamo that fixes it, that the Earth's magnetic field increases and then it decays over time, and then the dynamo increases it again. I don't need that assumption. All I go by is that the data shows that the rate at which it's decaying is a half-life of 1,400 years. That's all I need. There's no assumption built in there. That's scientific data. That's all that's based on. Okay.
I just showed you.
Assuming that there's a dynamo that restarts the thing over and over. What's the science of that?
Let's say the dynamo method is nonsense. There's no dynamo. It's done by gremlins. It doesn't matter. The point is, I don't need the dynamo. It's open science. I don't need that particular model to be true. What you said was the magnetic field has a half-life of X, and if you go back into the infinite past, it would be way too strong. Therefore, your model is wrong. I've shown you.
That's correct.
Okay. I've shown you the data that does not happen. Regardless of how it doesn't happen, doesn't matter. It does not happen.
Well, again, I point out that this paper, if assumed to be the case for the clays of the whole Earth, would contradict the data provided by secular scientists who measured the Earth's magnetic field from different locations on the Earth. So you see, there's a problem here. There's a disconnect. You're assuming that it had to be the same all over the Earth, but that contradicts the secular mainstream scientists' data. And that's the problem. So, I don't need an assumption. You assume there's a mechanism that increases the magnetic field of the Earth, then it's allowed to decay, then it increases. The only mechanism that could possibly do that that's ever been postulated by the scientific community is that the magnetic field is generated because the Earth's core is revolving, is spinning at a different rate than the crust of the Earth, because the core is spinning at a different rate in relation to the crust of the Earth. This is one of the things that causes geological activity, like earthquakes and subduction, various things, right? So they have to assume that rate is caused by the Earth's magnetic core. It's spinning, right? But the problem is, for it to increase means the core has to increase in velocity. For it to decrease, the core slows down. If it's generated by a rotating core, the rotation of the core is what generates the electricity, just like in an alternator in your vehicle. See, but there's no model. It doesn't even make sense to believe the Earth's core accelerates, then decelerates, accelerates. What could spin it up and make it move faster when the Earth formed by a nebular hypothesis and is slowing down ever since creation? See, it makes no sense. So there is no fixer for this problem, none.
So just to be clear, your assertion is that the clays that they fired all throughout the Near East, the magnetic field there fluctuates like a sine wave, stays kind of in the same area, but the magnetic field everywhere else, for whatever reason, doesn't do that.
No, I don't say everywhere else. No, I don't say everywhere else. I'm only pointing out that the secular data contradicts the idea that the magnetic field had to be the same on all over the Earth as it was for that clay when that clay was, made by ancient Jews.
I'm conceding the
I'm
dynamo for now because I have no idea, and it doesn't matter. The dynamo theory is nonsense. Throw it away. Who cares?
Yeah. Okay, good. So the Earth's magnetic field is decaying. That's what's up. That's just
false.
Observable, testable, repeatable science.
You can assert that all day long, but that's not the truth. And I just showed you the data.
I just showed you 4 scientific papers that talk about it. It's okay. So, Jordan, I don't know how to help you. I'm just going to point this out for you, and I hope you'll go research it. Secular mainstream scientists agree the Earth's magnetic field is decaying at a rate that gives it approximately a 1,400-year half-life. That's all they know. That's all they know for sure. Okay, and this is based on their own data. Okay,
every one of those papers, when they talked about decaying, we're talking about the rates right now. So you are assuming that those rates. You are assuming that those rates have stayed the same into the infinite past. That is an assumption of your model.
No, you see, it works like this, Jordan. That's observable, testable, and repeatable measures made in science. Okay,
you were there 50,000 years ago.
You're assuming that there is a mechanism that recreates the improves the magnetic field of the Earth dramatically, and that it oscillates. It gets stronger, then weaker, stronger, then weaker. But the only thing and there's no evidence for that. So that's an assumption. Secondly, against measures, observable, testable, repeatable science. I don't need to assume anything. All I can do is assume that the Earth's magnetic field is decaying and has always been decaying, because I don't have any evidence that shows it hasn't been anything but decaying.
I'm going to try to explain this one more time.
But you're assuming that there was a dynamo that fixes it. You can't even come up with a method, a logical reason to believe that that's plausible.
No, I already told you that I've rejected the dynamo for the for the purpose of this debate. It's gone. Who cares?
Great. So, then it's empirical. The Earth's magnetic field is decaying at a rate that proves the Earth can't be.
I'm going to try to explain this one more time. So what you did was you showed data that's examining this. You're saying for this period of time today, it's decaying at 6% or 8% or whatever percent. Okay.
Mm-hmm. Yeah.
And you're saying, therefore, that goes forever. Now, I showed you data that encapsulates this and also goes to here. And I'm saying, look, it goes like this. And you're saying, no, this is the data we should be using. Ignore the data that goes like this. So when I gave you more data, you said, don't use it.
No. What I'm pointing out to you, Jordan, is if you assume that data for those clay pots in Israel, or maybe even in several places in the Near East, is representative of the entire Earth throughout its history, then it contradicts mainstream scientists who've measured the Earth's magnetic field in various locations on the Earth for a century. That's all I'm pointing out. Okay, you're assuming that this pottery in one little place on the Earth at this one time in history somehow solves the problem for the whole planet. And it's just nonsense to believe that, okay? Because they publish the data. They agree with it. There's not an argument about it in science. They think it's fixed by a dynamo, but there's no logic to that and no evidence of it. That's all. It's observable, testable, repeatable science against a massive, crazy assumption. And you just verified that you're willing to believe that all of the scientific data published on the subject, which is even accepted by secular astronomers, cosmogonists, and geologists, that the Earth's rate is decaying, this magnetic field is decaying, is fixed by this problem. What's in your head doesn't concur with their data. Do you understand that?
What I think is that you're getting the data wrong. But rather than going into that, I'm just showing you the data I have. Now, what's happening is you see data you don't like that is bigger than the data you had. So you're going to say, I'm going to go with the data I like that goes with my model. That's not a good.
No, you have data that shows that magnetic field was trapped in some pottery when it was baked in Israel 1,500 years ago or something, or 2,500 years ago even, and you think this fixes the entire planet, and all the measurements that have been made, and secular scientists, mainstream scientists agree with, the Earth has presently a decay rate of 1,400 years.
Presently is the key word there. Presently.
So. Right. The problem is, if it's not always been this way, you have to have a geological mechanism to solve that, to make the Earth's magnetic field increase. What could do that except an accelerating core?
What you're doing is this. If I drop this dice bag, You're looking at it when it's in midway and saying, well, it's falling at this rate, therefore it is going to fall forever at that rate and has been forever. That is just false. That's not good methodology.
No, data taken from measurements over the last century show that it's decreasing.
Okay.
That's how you know it's decreasing. Not measuring what it is right now, Jordan.
No, my data.
Comparing that to how it was measured 20 years ago and 40 years ago and 60 years ago. That's why they agree the Earth's magnetic field is decaying at this rate.
My data covers the last century and also a lot more.
I'm going to jump in real quick, guys. Did you want to? No problem. I wanted to say thanks to the chat, for the super stickers, super chats. Lots of great questions coming in. We've got over 50 people in the audience. So guys, smash that like button if you have not yet done so, and subscribe if you're not subscribed yet. Did you guys want to take maybe a minute on this topic? Each of you of uninterrupted time, and then maybe we can move on to. Okay, I lost my spot as to who would ask the next question. Whose turn?
It's Neff's turn.
Okay, so did you guys want to just take, because I don't want to just, stop in the middle of a thought. Why don't you guys each take a minute and finish your thoughts on this specific topic, and then Neff, you can ask a question.
Okay, sure. I'll just point out that the mainstream scientists concur. The Earth's magnetic field is decaying at a rate which gives it a half-life of about 1,400 years. That's what they believe, globally. Okay, not just the guys that dug up some pots in Israel that are 2,500 years old, globally. This is what mainstream scientists have come to accept. There has to be a mechanism. My opponent's been arguing that this one study about clay pots found in Israel fixes the problem, and while at the same time it controverts the data provided by mainstream geologists. And that's just a ridiculous assumption. That's not even scientific to think that way. I think that's sheer nonsense. It certainly is not a scientific way to think. I'll just point this out. The erosion rate at which the Earth's erosion is...
Hold on, wasn't I supposed to get a minute and then you can go ask
your question? So well. Yes.
Yeah. Go ahead, Jordan.
So what Neff is doing is he's saying this is the rate today. Scientists agree that this is the rate today. Therefore, I have used this rate from today and calculated a half-life and assume that it lasts forever. He is taking what scientists have said, that it lasts today, and said, okay, and then he's gone beyond what the scientists said and come to his own conclusion, not backed up by the data. What I did was I showed data that undermines his hypothesis. Now, there's other data too. You can look at the basalt at the ocean floor. That also captures this data. It goes much further back into time, but I figured I'd do the clay pots. That's more fun. It's not talked about as much, but you can look at the basalts for yourself. Don't trust me. Don't trust Neff. Look at the data. Go ahead and ask your question.
Yeah, sure. So the more observable, testable science that shows that the Earth can't be millions of years old. Can I screen share, please? Thank you. The rate at which the continents are eroding proves unequivocally the continents can't have existed for millions and 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 millions of years. It's not possible. What you see right there on the screen is an apartment complex on the coast of California. When I've seen an interview with a man who's 36 years old and moved into those apartments when he was young. When he was young, there was a football field length of land between the apartments and the coast. It's gone. In 20 some odd years of his life, it's gone. This kind of erosion is being experienced everywhere on the earth, everywhere. And it's very common. Here is a house that lost everything. These people evacuated so fast they had to leave their patio furniture. The house is condemned. They can't go anywhere near it because the ocean is just eating it away. This is in England. Sidmouth Cliff homes losing a meter a year to the sea. How many, let's just pretend there's been 1 million years in the past. 1 million meters of Britain disappears every 1 million years. Now, the only thing my opponent can do is say, well, you're assuming that the rate of erosion, the arguments from the evolutionists, the rate of decay of the magnetic field, the rate of erosion, the rate of genomic decay, it's always hand-waving. You have to assume that the rate of erosion for the continents has always been the same. Are you going to tell me the oceans have been pristine and calm and flat like the surface of a piece of glass for 500 million years? And then they get rough. And then they calm down again. And they get nice and easy. And that lasts for millions and millions and millions of years. Then for 5,000 years, they're rough.
Do you have a
And then
question?
they get calm again. What my question is, how in the world is it possible for uniformitarianism to be true since the Earth's continents are eroding at a rate of 280 billion tons into the sea every year?
Okay. What rate are they increasing? What rate is new rock and new dirt being produced?
Minuscule. Volcanic eruptions add, a football field worth here and there, a couple of times a century, maybe.
So what you've done,
If that,
again, is you looked at a present rate, assumed it must be constant forever, always, amen, and then
Yes.
applied it universally.
so
That is like
what causes erosion?
that is like looking outside, saying it is hot today, or saying it's snowing, and therefore it can't possibly ever get hotter because
So
it's
you're
snowing today.
saying you believe that the rate of erosion could have been not just a kind of slower, dramatically slower, way slower,
I believe
like really slow
that
for millions of years?
it is
What
not as simple as saying this is the rate today, therefore it was the rate a million years ago.
What would cause the rate to be dramatically less? And it would have to be like thousands-fold slower.
For example,
Wouldn't it be that the oceans had to have been vastly more calm, nearly calm?
No.
Wouldn't that be true?
so for example, you can have differing local conditions. You have the Messinian salinity crisis in the Mediterranean, where the Mediterranean was completely cut off from the rest of the ocean for a long period of time. That caused it to dry out. We can see the evidence in the thick layers of salt there. And so certainly you'd have less erosion there because you'd have less water there. That's just one tiny example of how you can't look at how it's eroding today in Italy and say, well, therefore it eroded like that forever. That's just nonsense.
Okay. So great. But the erosion is disappearing all over the world, right? I showed you England. I've shown you California. It's the same everywhere. The rate at which it's decaying is phenomenal. Okay. What you see on the screen is Sidmouth in England. You can see from these photographs made in 2008, 2016, and 2018, 1 million tons. It's gone. It's just gone. And this is occurring everywhere on the Earth. Now, you're saying you're complaining about the rate at which it's eroding and saying your complaint is that I believe it had to have been a constant rate. So isn't it true then you're arguing that the rate was infinitesimal compared to what it is today throughout the vast history of the Earth's geology for the continents not to have eroded away?
No.
Is that what you're saying?
No, what I'm arguing is that life is more complicated than your very simple model. In fact,
No, but that's not an answer.
It's not an answer you like, but it's an answer.
No, that's not an answer.
Okay, I don't care if you like it. It's the answer. So
you don't have an answer.
I happen to live near Virginia Beach, and I can go there. I've been going there my entire life. I'm about 30 years old, and the beach is still there.
Yes.
So it is not true that you're getting this dramatic level of erosion every single place where water meets the earth forever. Like, that's just demonstrably not true. What you've done is you've looked at the most extreme examples of erosion possible, said, look at these extreme examples, and then pulled out the argument of personal incredulity. I personally cannot imagine a way where this could happen. Therefore, it's false. Therefore, every single geologist on the planet has no idea what they're talking about. Like, that is not a good argument. You haven't shown any data showing the production. You've asserted that it's infinitesimal, but you've shown absolutely no data to support that assertion. You've shown no data to show that it is eroding at that rate everywhere. You've shown pictures, but that is not data. All you've done is you've shown some pictures, told a story, and then made an assertion. That's not science.
Oh, no. So you're just hand waving the amount of the erosion problem. So how many dump trucks worth of sand have been dumped on Virginia Beach in the last 20 years to keep it from eroding so they can keep their precious millions of dollars of tourist money?
This might surprise you, but I am not a civil engineer working for the Virginia Beach government, so I have no idea. But it's not the washing away of the hotels in the few months level. So, I can tell you that.
I'll just, maybe you're not aware of it, but beaches all over the world, the local authorities, they bring dump trucks worth of sand to their beaches and spread it every year because they have to, or they won't have the millions of dollars in tourism because the beaches are disappearing. So I understand that for you to believe the Earth is millions of years old, you've acknowledged that the erosion rate can't be what it is. Because you point out that I'm assuming that the rate of erosion is constant and it's been this way over millions of years. That's correct. I do assume that. You're believing in some imaginary process which could have caused the rate of erosion for the continents of the Earth to be dramatically, and I mean way, 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 way less for the vast majority of the Earth's history. Else, because in only 20 or to 30 million years, there would be no continents at 280 billion tons a year. No continents at all. The Earth would be a bottle of water. So you're having to believe that throughout almost the entirety of the Earth's history, the rate of erosion was infinitesimal compared to what it is today. For that to be so, the oceans of the Earth would have had to have been calm like a swimming pool.
You say that, but you show no data to show that.
Can you give me another explanation?
Yeah, things are more complicated than your extremely simple model.
Great. Thanks.
So anyway, let's go back to cosmology. I don't think you mentioned this today, but I know you've mentioned in the past that you think that you can't have inflationary cosmology because it violates some special relativity maxim. And that's why you think there's a problem. That's the horizon problem. Actually, you did mention it today. So the solution to the horizon problem, one of the going solutions, it's not the only one, but one of the going ones, probably the most popular one, is inflationary cosmology. So the way that works is the universe originally was in a very hot, dense state. It was small enough that you could communicate throughout. That's why it was mostly homogeneous, but you have quantum effects that have small changes. And then it went through a period of rapid inflation that expanded it to close to the size it is today, and that's why you have a very stretched out universe that's about the same in every direction. That's the model. Now, I presume you think that model doesn't work.
Yeah, and there's problems with that. The circular camp acknowledges the problems with that. Nobody knows that inflation actually happened. It's postulated to fix a problem. It's just another example of where scientists invent something to try to solve a problem. Inflation causes problems. First off, it does violate the laws of physics because it requires the universe expanded at a rate vastly faster than the speed of light. Okay. And that doesn't seem to make sense. Let me share with you something. Let me try to screen share this with you, and I'll show you that I'm not just blowing hot air. I want you to see something for yourself. Maybe you're not aware of this, but Eric Lerner, a New Scientist writer, states, the theory of inflation predicts that today's universe should appear uniform in the largest scales in all directions. That uniformity should also be characterized by the distribution of fluctuations at its largest scales within the CMB. But these anomalies, which Planck confirmed, such as cold spots, suggest this isn't the case. This is very strange. And I think there's really something to this, et cetera, et cetera. It doesn't fit inflation. From cosmic inflation at New Scientist, they state, inflation was invented to explain a couple of features of the universe that are really hard to explain without it. The first is Einstein's general theory, et cetera, et cetera. And then there's cosmic inflation from a New Scientist that stated again, inflation is now a built-in standard for the cosmic theory, but it's controversial. In 2014, researchers claimed to have seen ripples from inflation imprinted in the cosmic microwave background, but this is proven a mistake, et cetera, et cetera, et cetera. And then from these scientists at Scientific American, how much more secular can you get than that, state that the latest measurements of this where they concerning this inflation show that the idea of inflation is just an invented idea. There's nothing, it was invented to fix a problem with the secular Big Bang. It works like this. Well, that just doesn't work. Oh, I know. It inflated real fast. Well, how do we know that? Well, we don't, but it seems to fix it. Great, plug it in. That's how they work. That's the way secular scientists work.
So
you know that by now.
Your last one, I'm actually familiar with that one. That was a article in a magazine, which famously is not peer reviewed,
No,
but it
it's
was
published by these scientists whose names appear at the below.
yes,
Yeah.
which isn't a peer reviewed source. So those scientists
Scientific American published it.
is not peer reviewed. So
Because,
those scientists, they are actual cosmologists, and they are of the opinion that inflationary cosmology doesn't work. They are perfectly free to have that opinion. They're perfectly free to publish about it. What they did, there was a refutation to that written by 30 some odd cosmologists. And basically what's going on is those people are saying these models of cosmology of inflation don't work. What the other cosmologist said is, sure, but there are many models of cosmology. That's not a bug, that's a feature. The idea of inflation can have many different variations, just like the standard model has had many different variations before we figured out
of it.
Before we figured out which one actually fits our observations. That's how science works. We see observations, we come up with a hypothesis, we test it. If those hypotheses don't work, we get rid of it. That's how science works.
So what you just acknowledged is that they did invent it because they needed something to fix the problem, and there it works. By the way, Arno Pens accept the data, that's all. Accept the data. Not invent an entire idea, something like dark matter or dark energy, and plug it in. Dark matter surrounds the spiral galaxies and holds it together. Shh, we can't see it, but it's there.
You can say it in a silly voice if you want.
This is the kind of thing. So it's not, Arno Penzias. Is he accepted? Yeah, he is. He agrees cosmic inflation is contradictory. There's no scientific evidence for it, and it's problematic. They just don't have any reason to believe that matter in space could expand faster than the speed of light. That's all.
Okay, so two things. First of all, you can say it in a silly voice if you want, but we can actually detect the effects of dark matter. We can't detect it directly, but we can detect its effects because we can weigh galaxies. We can weigh galaxies, and there's more matter there than we can see visibly. Therefore, that's dark matter. That's just what it is.
Can weigh them. How do you weigh a galaxy?
Using gravitational lensing.
Right. Right. So all that means is when they shoot a laser beam into space towards a galaxy, it bends. Mm-hmm. That's all it proves.
Right. That's how that's what general relativity.
Right. Well, the galaxy has gravity, don't you know?
Yeah, that's why you have to use general relativity.
Right.
So speaking of general relativity,
all that proves is that we don't understand something about the galaxy. That doesn't prove dark matter is there in massive quantities, secretly holding it in. And about that, since the galaxy is flat, how does the dark matter would have to surround the outside of the disk of a spiral galaxy much more than the top and bottom of it? How does that work?
Speaking of general relativity, you said that nothing can move faster than the speed of light. You declared that. That violates a law of physics. What law of physics specifically does that violate?
Well, it's just known that the fastest thing that man observes is light. That's all.
Okay. So the answer is
we don't know of anything that moves faster than light.
The answer is special relativity. That's the answer you were looking for. It violates special relativity. But special relativity does not include gravity. Special relativity is a theory posited by Einstein that assumes a flat space-time, and it governs things talking about in local inertial reference frames. Things moving in a local inertial reference frame will view the speed of light. That's the same for all observers, and no observer, because of that, it's an implication of that assumption, of that underlying principle. No observer will be able to go faster than the speed of light in their local inertial reference frame through space.
So what makes light go faster than light? What makes energy go faster than light?
So that's actually not what we observe. What's happening is you're taking a principle of special relativity, but you're ignoring general relativity. So general relativity was the theory that superseded special relativity. Special relativity is a special case of general relativity. It works on small scales where the curvature of space is not important, but general relativity takes special relativity and adds gravity. So whenever you're talking about space itself, you have to use general relativity. And in the case of the expanding universe, it is not the case that things move through space faster than the speed of light. They did not. What is the case is that space itself
is expanding. I got it. I know. Right. I know.
And that violates nothing. That doesn't violate anything. It's perfectly consistent with general relativity, which is the correct theory to apply when you're talking about space.
That can't have happened. How did that happen during the first 10 minutes of the universe, though?
Well, you'd have to get into a model-specific discussion because there are a lot of different models, but the basic thrust of it is the idea is there's dark energy or some other driving force that led to inflation. It is still an open question, and I'm not going to apologize for that. Open questions in science are a thing.
What needs to be understood is that these postulates that you and your camp put forth are ideas in their head, but none of them are observable, testable science.
False.
That's it. They
You
come
can
up with something.
absolutely
No,
observe
that's
inflation.
not true. It is true, and that's why your camp says that spiral galaxies are held together and don't come apart because dark matter is surrounding them. But I pointed out a problem with that. Spiral galaxies are flat. They're like a disk, right? And they're vortex. The arms of them are spinning 10 times too fast. They acknowledge that. And they fix this with the imaginary dark matter. The problem is, let's imagine that's true. Then dark matter surrounds the outer edge of the galaxy with a massive amount of it to keep the arms where they are, to keep them pushed in so they don't spin out. So why would the dark matter collect only around the outside of a spiral galaxy, even though let's just pretend it's really there, because nobody knows for sure. This is just an idea in the head to fix the problem. Why would it be there instead of on the top and on the bottom equally? And why can't they find any of it in our galaxy?
So first of all, you can actually detect inflation directly. We can't yet, but it is hypothetically possible. The way you do this is through gravitational waves. So gravitational waves are waves in space-time. We have detected them very recently, 5 years ago with a LIGO. We detected them for colliding black holes, and we recently detected them for colliding neutron stars. However, the magnitude of the gravitational waves that those things produce, despite how massive they are, is very, very large compared to the gravitational waves that are predicted for most inflationary models. So we don't have the sensitivity yet to get to detecting those waves, but it is very probable, since it's a very new technology, it's almost certain that we will get to that sensitivity at some point in the next few decades. And then we'll be able to falsify a huge swath of models. If we get to the point where we detect those very small gravitational waves, but we don't detect them for inflation, then the inflation will be falsified. That is the definition of a falsifiable model.
No, things that you imagine in your mind exist. That you don't have observable, testable, or repeatability for is maybe a model in your imagination.
What do you think relativity was prior to the observations of relativity?
There just isn't any observable, testable science to show that dark matter is surrounding spiral galaxies and or that inflation actually occurred. Nobody knows that inflation occurred. It's just a postulate. It's
a postulate right now that we are working on confirming. Just like relativity was a postulate, and then we confirmed it. That's how science works. I don't understand what you want us to do.
The problem is that all your ideas that fix everything about the age of the Earth and everything else is postulates. It's not data.
Until we have data to confirm them. Do you think that we have data to confirm relativity?
There's no data that confirms anything that demonstrates the Earth is millions of years old.
Do you think we have data to confirm relativity? You used it, so I assume you do.
Well, yeah, I wouldn't argue against relativity.
Okay, then if you accept relativity,
the Earth is millions of years old.
If you accept relativity, then you need to accept dark matter, because we use relativity to show dark matter through gravitational lensing. You can't have one without the other.
You use relativity to explain a mathematical model on a chalkboard. That's what you do. The idea in your head. It's not something measurable, observable, testable, or repeatable.
It is observable. Relativity is detectable. You can. Your GPS
dark
depends on.
Matter is not, and neither is are any of the postulates about the magnetic core or the anything else about the age of the Earth.
So
These things are ideas in your head that don't have science that backs them up. That's all.
If you and I had been talking 100 years ago, when Einstein was coming up with these ideas, what you'd be saying is Einstein just has these ideas in his head. They're just postulates, and all you darn evolutionists are. Newton's laws were just fine. The way the scientific method works is you see an observation, you come up with a model, then you test the model. We are in the process of testing the model. I don't know what process you want us to use if we can't come up with models and then test them. Maybe you don't like that we change our mind. Maybe you don't like that. Maybe you would prefer that we never change our mind for new data. But I'm sorry, that's not how science works.
Well, guys, I'm just going to jump. Oh, I'm just going to jump in real quick and point out, and you guys can finish your thoughts. We're now going on actually 60 minutes. Time has flown by. It's been a great discussion, great debate. 60 minutes in terms of the discussion. So we've gone 10 minutes over the agreed upon 50 minutes. Did you guys want to do the same you guys did on the magnetic field? Maybe provide a couple minutes each, uninterrupted time to...
Why don't we just roll into the closings and we can just bundle them together?
Okay, let's do that. Yeah, because I'm open to suggestions, whatever you guys want, whatever you feel like is. Because I want to make sure you guys both feel like you've been able to present all of your points fairly. So why don't we go right into the closings? And do you guys feel like 5 minutes uninterrupted time will be enough to kind of wrap everything up and do a
I don't
conclusion?
need 5 minutes, but we'll do it 5 if Jordan wants, however long he wants.
5 minutes should be fine.
Okay, go ahead, Jordan. Floor is yours.
So what we've seen a lot today is we've seen taking a very small slice of data and an instant in time and projecting it into the past, which doesn't work in the actual real world. You have to use calculus because things change. You have to verify your assumptions. You can't just project them in the past willy-nilly and then declare that they don't work. We saw a lot of misunderstanding with things like the second law of thermodynamics, confusing complexity for entropy, which is a common misconception. It is a normal thing for someone who hasn't studied the topic extensively to not understand. But that kind of leads into what I'm talking about here. I'm not going to spend my entire closing relitigating the debate. If you want to hear my arguments, you can go back and listen to them. Instead, I want to talk about a little bit about bias and expertise. So I started this talk off by saying I'm an engineer. But just as important as what I am is what I'm not. I'm not a physicist. I'm not a geologist, a biologist, or any other kind of scientist. I'm not an expert in any of those fields. It may seem odd to some people that I profess my own lack of expertise, but nobody can be an expert in everything. There seems to be that there's too much human knowledge for any one person to possess it all. Throughout this debate, I presented just a small sliver of that knowledge that clearly points to the old Earth and the universe. But I'm not going to possess all of human knowledge. The ideas I presented, though, are not controversial among those who are most informed on the topic. Upwards of 99% of geologists, physicists, etc., people who are experts, agree on the age of these things. That includes atheists, agnostics, Christians, Jews, Muslims, Hindus, and every other persuasion you can think of, regardless of their philosophical commitments or their intellectual background. All of these highly educated professionals all look at the evidence and come to the same conclusion. So science is not a popularity contest. I'm not saying that just because all of these scientists agree, that makes it true. That is not what I am saying. However, this widespread agreement should give us, as laymen, pause when we talk about this. Laymen, like Neph, like myself, like everyone listening probably, should have humility about the knowledge that we possess. This is something that people are terrible at. I'm terrible at it. I have to consciously pull myself back, and humans are biased creatures. This particular bias is called the Dunning-Kruger effect. People who know very little about a topic tend to be extremely confident in that topic because they don't understand the nuance and the exceptions. See the example of second law of thermodynamics for a clear-cut case of this. To ensure that you're not falling into this trap, I recommend asking questions and being humble. Rather than simply saying, man, those scientists seem so dumb. How can they not see how obvious this is? Those idiot scientists. Ask the question, man, this seems super obvious. Why aren't all the scientists convinced of this super obvious thing? Like, why do the people who spend their entire lives studying this not see this when I, a person who've studied it for 5 minutes, understands it? Then, and this is critical, go find out the answer from the scientists. Maybe all of those scientists are wrong. Maybe they're all dumb, biased idiots who can't see the truth staring them in the face. But maybe, just maybe, the reason they aren't convinced is that they understand more of the topic than you do. The great thing about living in the age we do is that you have all of this knowledge at your fingertips. You just have to be humble enough to seek it out. While you're seeking, remember, if the creationist model is wrong, you're not going to find it from Answers in Genesis. So make sure you get out of that echo chamber. That's why I engage the creationists. If I'm wrong, I want to know. That's why I talk to them. And also because I used to be one. So I hope we're all interested in finding the truth. If we're wrong, we should want to know it. The best part is if you find out you're wrong, you just change your mind and poof, you're not wrong anymore. Easy peasy. I hope you all feel the same way. And if nothing else, I hope this debate has armed you with better questions to ask. Asking questions is vital, and we shouldn't be afraid of the answers. We have nothing to fear from asking questions. We have nothing to fear from the truth, for as it is written, the truth shall set you free. Again, I've been Jordan. Check out Reason to Doubt. That's number 2 because there's 2 of us. And thanks for having me on.
Awesome. Thank you. Okay, perfect. That was about 4 minutes. Jordan, this debate has flown by. Great intros, great rebuttals, very lively discussion. I think we touched on a lot of really, really good topics. So the audience has had a good time. Neph, the floor is yours. You have up to 5 minutes, so take your time.
Okay, so I hope what people will take away from this debate is that I provide data and hard questions about things that demonstrate the Earth cannot be millions of years old, and my opponent hand waves them or says, well, we have an idea about something we can imagine in our heads that fixes it. That's what you need to take away. So you should also take away from it that I'm prepared to discuss numerous features of the Earth about how we can know that the Earth is not millions of years, and my opponent seemed unprepared for that. So this is very typical. Evolutionists concoct an idea in their head. Well, there must be a dynamo that fixes the problem. Oh, there's lots of dark matter surrounding the galaxies, and that's what holds the spiral galaxies together. Oh, well, inflation fixes that. These are ideas in the heads of them that they just concoct, and they allegedly fix the problems. And we saw the greatest example of that, whereby my opponent admitted without directly saying that he was willing to believe that the rate of erosion for the continents had to have been absolutely minuscule compared to what is observed and measured all over the world today throughout the vast history of the Earth, of the planet, in order to fix uniformitarianism and keep the continents from eroding into the sea in only 20 or so million, less than 20 million years. So this is how in evolutionists values their worldview much more than science. The truth is that atheists and evolutionists alike value their worldview, whether they're atheist or whether they're a believer in God and a staunch believer in evolutionism and world and uniformitarianism. They value those beliefs more than they do data, and more than science, and more than the scientific method, because they are willing to just invent all kinds of ideas, plug them in, and say, well, that fixes that, and it does no such thing. So think about imagining that the oceans of the Earth were not eroding the continents at this rate that's measured by geologists all over the world, not just in California, but all over the world, and believing that that rate can't have been constant throughout the history of the Earth, as though the oceans have not been harshly lapping at the continents and rain has not been eating the continents away and dumping into the sea like it is now. What kind of Earth did we have for the uniformitarianist? Well, it's easy. The oceans were smooth and flat for millions upon hundreds of millions of years. There was very little wind at all, and it never rained. That's why the continents are still here. See? Because the rate of erosion was outrageously small compared to what it is today, and that fixes the problem. How do we know? That's how science works in the head of a uniformitarianist. Whatever has to fix the problem for me is a fact, and they're going to call that science. And I think that's what you should remember about this debate. And that concludes my closing statement.
Awesome. Okay, perfect amount of time, 4 minutes as well. So equally timed. Like I said, debate has flown by. Now, I will say, Jordan, as usual, most of the questions are for you, but I have, so you're a good sport. I appreciate that. You're in the lion's den. Now, I have said recently a couple times in the chat that if there are any last minute questions from, let's say, the evolutionists for Neph, throw them my way and I'll make sure to get
top of the pile.
We'll put them to the top of the pile. We'll try and make it as even as possible. So anyways, let's get right to the questions. And I will say, guys, we've got an after show on David Neff's channel after the debate here. So let's go. First question. First off, I want to say thanks so much for all the super stickers, guys. I appreciate it. Doki, you've won again. You can't be beat. Okay, so let's see here. Here's a funny one we'll start off with. I'm going to go through the super chats. Doki Doki Bible Club says, question for Neph. Angel wants to know if rocks bend.
Okay, rock bends when it's 10 to minimum of 10, more likely up to 20 kilometers down inside the Earth, where the temperature is great enough to allow the rock to become experience plasticity. So says geologists, mainstream geologists are uniform in that belief.
Okay, awesome. Okay, question for Jordan. from Redefine Living. Question is, what is the difference between isotropic and anisotropic? And why is it relevant regarding starlight? Anisotropic and isotropic.
All right, so Google says that isotropic is having a physical property which is the same value and measured in different directions. And I'm assuming anisotropic is different value. Yeah. So I assume this has to do with the CMB. The CMB is mostly isotropic when you look out in every direction, but it is not completely isotropic. There are anisotropies. I hope I'm pronouncing that right. I probably am not. There are small unconformities. That's why the picture is not just one color. You have variations. Those variations are very, very small. It's believed that's because they're due to quantum effects. So, also the Doki Doki thing, I love that game. So, that's pretty nice.
Yeah, we appreciate Doki Doki. Thank you so much for the $10 super sticker there. Redefined Living, he clarified that why is it relevant regarding starlight? But I guess you kind of addressed that in your...
I think so.
Okay. No, I just want to make sure that, because I didn't finish the rest of that question. Neph, if you have anything you want to say, I can go to the next one.
No, I don't have anything.
Okay, so next question here. Actually, somebody said there's an echo. Let me see. I want to make sure. David Neff says he's hearing an echo. If there is an echo or any audio issues, let me know. Okay, so let's see. Next question is from George Bond. Question is for Jordan. Thanks for the question, George. He asks, how do you explain the heavier elements created by Z-pinch and the ratio of parent to daughter being at the same ratio as those found naturally on Earth?
Okay, so Z-pinch, for those who may not be aware, he's probably talking about the hydroplate theory. And the idea is you have a bunch of vibrating plates. Actually, I heard about this first from SFT in that other debate where I'd never heard that before. So that was pretty cool. So the way I talk about this, first, the hydroplate theory basically is trying to get a way to get heavy elements, radioactive elements on Earth without having them before the flood and stuff like that. The way that heavy elements are actually produced in large quantities is in the hearts of dying stars and supernovae, and also we found out more recently with colliding neutron stars. So those heavy things fuse together, you have enough there, and that disperses it elsewhere. The reason that they'd be about the same for like on Earth, or if we go like to an asteroid, and if we go to the moon, that they'd be about the same prevalence, is because we all came from the same stuff. If we have this disk, and again, there's a lot we don't understand about this, so anybody who tells you they understand that completely is probably lying to you. If we all come from the same stuff, we're going to have about the same prevalences. So I think that answers the question.
Awesome. Thank you for answering that, Jordan. Neff, did you have a response at all?
Yeah, I'd say that there are insurmountable problems with secular astronomy, cosmology, cosmogony, and they invent things, ideas in their head, which fixes problems that are unsolvable, and then they call that science.
And Jordan, to be fair, as we like to do here, the question was for you, so you can have the last word. Okay, awesome. And Neff, I appreciate the $10 super chat. Says, thanks for moderating this debate. It was my pleasure. It was a lot of fun. This was definitely probably one of the best debates we've had. So, guys, you kept this fun and exciting. Yeah.
Heated, but good heated.
Yeah, exactly. Hey, listen, a lot of these debates, they oftentimes do get heated, but there's no reason why we can't, because you guys are passionate. We shake hands at the end of the day anyways.
I'd buy him an ice cream cone.
Am I invited?
Yeah, sure.
I'll buy you a beer, or maybe me a beer, and you an ice cream cone.
Well, okay. How about we meet in the middle ground? We go to Starbucks and I get us a coffee.
Coffee. Neff, you know I'm always down for a coffee. Okay, so let's see. Okay, here's a question that came in that I can at least screen share, make it even easier. Here we go. M. Preziv. Hope I didn't butcher that. Question for Jordan. Why does he think 3D models are an accurate representation of reality and can be used in the scientific testing methods?
Okay, so it's hard to say unless I know exactly what 3D model he's talking about. But we definitely use models when we're modeling things. For instance, in my field, nuclear engineering, we'll use 3D models of, say, the nuclear core. and I know they use models. The reason that we have to use models is because physics is super complex, and when you're trying to explore new theories or when you're trying to figure out how things work, you start with a model to vet your ideas or to see what happens when you change X or Y. Ultimately, you have to test those predictions that you use your model to produce against reality. And it doesn't matter how well they work on your computer. If the predictions you made in the physical world aren't borne out, then it doesn't work. And you go on to something else.
Awesome. Thank you, Jordan. Did you have a response at all there, Nev?
No, I guess no response for that.
Okay. Let me see here. Doki Doki, thank you so much for the super sticker. And question for Neff. Neff, Mr. Popular here. You assume that erosion stayed at a semi-standard pace. What about the Ice Age? What about the fact that there is less land mass now than 1,000,000 years ago?
Oh, great. That's easily explained. It's the flood of Noah that brought the Ice Age on. I can explain the geologic process which caused that, but it relates to the amount of exceedingly warm, if not hot water dumped into the oceans that came from within the Earth, raising the temperature of the Earth's oceans dramatically, while volcanic activity globally darkened the skies, blocked out the sun with volcanic ash, causing the upper atmosphere to become ice cold. And when that incredible evaporation from much warmer oceans went upward into the high atmosphere, it became a snowstorm like the Earth has never seen before and never will again. And that's what caused the Ice Age. The fact that the landmass, landmass was greater on the Earth before the flood than now is just evidence of the flood. The continents have sunk down, and the continental shelves that exist in shallow seas around the continents is geological evidence of the Noahic flood. It can't be explained by uniformitarianism because the upper edges of those are sharp, and they have giant canyons carved in them. So if the oceans had existed for hundreds of millions of years, the edges of the continental plates underneath the sea couldn't be so sharp. They would have been completely sloped off by erosion, but that's not the case. So they haven't existed that way for millions of years. It's not possible.
And Jordan, if you'd like a response, go ahead.
My wife, before I went on this debate, said she was going to make me a shirt that's like Google autocomplete, says I'm not a geologist, physicist, biologist, et cetera, et cetera, et cetera. I've already given my answer. If you want an answer to that, the best place to go is to a geologist. They'd know way more than I would.
Actually, I think you just gave us an idea for our next shirt.
Don't go taking my ideas now.
No, I know. You'll get some of the proceeds. Don't worry. And Neff, a question was for you, my man, so you can have the last word there.
I would just say, well, Jordan needs to brush up on geology. I mean, after all, he's talking about the age of the Earth and his belief that the Earth is of an unfathomable age. If you're going to be able to make solid arguments for that, you better learn some things about geology.
Okay, let's go to, thank you, Neff. Thank you, Jordan. And let's see here. One Punch Man asks, question for Jordan. How can explosion out of chaos create order?
So I presume he's talking about the Big Bang. It's a common misconception, but the Big Bang was not an explosion. It was actually an expansion. The universe expanded, and that means all the universe, so not just like we expanded from this point, but all of the universe expanded. It turns out that the universe was in a low entropy state at that point, and entropy has been increasing over time. So we are at more entropy now than we were when the Big Bang started. So again, the second law doesn't say that you can't have localized increases in order. Ice freezes, and that's a localized increase in order. As long as things progress according to natural laws, entropy is going to increase, and as long as that is satisfied, the second law is satisfied.
Okay, so my word on that would be the Big Bang was an explosion. The Webster's Dictionary definition number 2, a large-scale, rapid, or spectacular expansion or bursting forth. So evolutionists say it wasn't an explosion. They think they're fixing the problem of where's this giant capacitor, which would be God, that caused it to spark it off. And they don't want to believe there was one, so because the universe can't have had a finite beginning. And so they deny that the Big Bang was an explosion, but according to the definition of explosion, that's precisely what it was.
Go ahead, Jordan.
So, real quick, if you want to get your scientific definitions, you should get them from scientists. It doesn't mean explosion in the like a bomb. That's all it means. In terms of like where it came from, that's a great question. Nobody knows. We still are working on it. But even if God did it, all that would do is get you to deism. That doesn't get you to theism. So.
And okay, thank you, gentlemen. Damian Garcia with the $20 super sticker says, you guys are awesome. Thank you so much, Damian. We appreciate the support. You guys are the reason why we're able to put out so much content. So we appreciate it. And CIH says, I missed his question. Let me go back to my list of 100 questions here. Okay, I found it. CIH, question for Jordan. Assuming your uniformitarian doctrine, studies over many years have shown a consistent decay rate in Earth's magnetic field. Well, I guess you guys talked about this for a while. At this current rate, in as few as 25,000 years ago, the Earth. I just read that word for word. You can respond.
Yeah, so you can just go back to that. we beat that horse like until it was disintegrated.
No, you guys only talked about it for about 35 minutes. I want another 35 minutes on that topic.
Just go for the debate.
Neff, do you want any final words on that one, or
no thanks?
David Neff, let me see. Question for Neff. Why did you claim the paper in Nature? He's claiming there is a paper that was deleted, but he found it.
Okay, so whether that may have been a mistake on my behalf. I searched Nature for it, the title of the paper, and it did not come up. So if it's actually there, I was not able to find it. If it's still there, I have a hard time understanding how a search from their own website doesn't produce it. I don't know. I can't understand that. I searched their website. I showed you a screen cap of a search using the title of that paper, and the search results was 0. That's why I provided that. I do have examples. I know of examples whereby secular mainstream scientists have even modified the title of science papers because of the implications of the data they're in, or they've removed them. And Dr. Michael Behe is an example of that.
All right. Doki Doki Bible Club Super Chat. Looks like Doki's just having a little fun with you, Jordan. So Doki's coming at you. $2 Super Chat. Thank you so much. Doki says, are you a geologist, Jordan?
You know what? Yes.
Yeah. He's been fooling us this whole time. I can see your PhD behind you on the back of the wall.
All been elaborate ruse.
Yeah. Anyways, yeah. Hey, guys, thanks for keeping this fun. Definitely been one to remember. So Godzilla Freak has a question for, take a guess, Jordan. So, if the magnetic change is oscillating, why are all other planets also decaying? Shouldn't they be out of sync? Some growing? Question mark.
So I'd have to see the data that shows that they're actually decaying. I did look at some data when I was checking the claims of a creationist that was making basically whatever. Doesn't matter what it's predicting. The point is, I haven't seen that data, so I don't know. But if you show me the data, I'd be happy to look at it. In fact, you can go to my Facebook page, reasonitedoubt.com, and then I will, or Reasoned It Out on Facebook, and I will definitely look at it.
Awesome. Nap, did you have anything to say before I go to this next one?
No.
Okay. 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 Doki Doki Bible Club. Coming at you, Jordan. No, this is a nice question. So $5 super chat. Thank you so much, Doki Doki. I appreciate it. If you lose faith in dating methods, Jordan, will you become a young earth creationist again?
That's a good question. I don't know. I stopped being a young earth creationist because I didn't think the data supported that conclusion, but I'm perfectly open to changing my mind from new data. So I don't think so, just because the information from cosmology is also pretty good. But if I lost all faith in radiometric dating methods, that would certainly make me less certain.
Awesome. Thanks for the answer. Thanks for the good question there. Doki doki. Okay, guys, we're going on over 2 hours. This has been a great debate. I know there's an after show as well, so I don't want to keep everybody here all night. Thanks for the super stickers. Thanks for the support, the super chats. Also, of course, thank you to the debaters. Without you guys giving us your time for tonight, we wouldn't have had this amazing debate. This was a lot of fun. I had a blast, guys. I'm going to hand it to you guys just for some final words, final thoughts. Plug your channels if you'd like to, and then we're going to call it a night. Whoever wants to start, thanks again for doing this.
Jordan, you can go first since you started. We'll just end that way. You start and then I go, and you start and I go. How about that?
Sure. Yeah. So, like I said, this is a lot of fun. Thanks for Neph for coming on too. I had a blast. If I'll go on the after show too, but if you liked what I had to say or you're interested in hearing more, you can check out our podcast. It's Reason, the number 2 Doubt. And we don't just talk about things like this. We talk about aliens. We talk about flat Earth. We talk about all kinds of stuff. Just applying skepticism. I think there's something there for everybody. And yeah, so check it out and let me know what you think. Thanks.
Well, Neph and I are both flat earthers, so we'll definitely join you one day. No, I'm just kidding. Hey, Neph, you better give a disclaimer. No, we're the Earth definitely wrong. Someone's going to clip that out, and there's going to be a title of a video: Neph and SFT flat earthers.
I'm already working on it.
Yeah, already working out. Here we go. Hopefully, it gets lots of views. Anyways, just joking. Neph, floor is yours, brother.
Oh, I've enjoyed this debate. Thank you, Jordan, for debating with me this evening. Debate is one of the things that really tickles my toes, and so I've had a good time, and I hope people cause people to think about things and maybe question what they believe, and I enjoyed it. I'll see you in the after show.
Awesome. All right, guys, a lot of fun. We had over 50 people in the chat having a good time, and one final super chat. Doki doki, one final reminder. David Neff after show. Now, I want to wish you guys all a good time. I'll join a little later. I promised the wife a movie night. I've been doing a lot of videos this week. It's been busy. So I want to say have some fun, guys. Keep it respectful, but not too respectful. Sometimes we like a dumpster fire. I'm just kidding. So anyways, yeah, great job, guys. This was a lot of fun. And let's see, anything else in the chat? No, we're good. So anyways, guys, everybody have a good night. And